think it's so neat. I'm the second talk in a row to have 3 ChatGPT images on the screen. And the reason that I have these up here, I thought we could play a quick game. I gave ChatGPT the agenda for today and asked it for some images, a whole bunch, and picked out a few. And for the game, the ask to ChatGPT was to give a hint that some of us would guess the image right, but some of us would guess wrong. So we can play the game real quick. The clue ChatGPT gave where light meets the depths. You can think to yourself, which image is it? And this is the one that ChatGPT picked out. Maybe some of you got it right, maybe some of you got it wrong. The reason I wanted to start with that game is, to me, that's demonstrating that this technology, the ability to follow instructions, generate information, and perhaps evidence of some logical reasoning. I'm starting to refer to this technology as artificial imagination. And my goal today is to see if we can use artificial imagination to help communicate sea-level science. This is how ChatGPT defines this type of AI. The key words here to me are generating novel information. Again, the objective, my objective here, is to collaborate with this technology to better understand and communicate sea-level science. And I think I come about this communication aspect. My formal training is in climate science, so learning about sea level was on-the-job training, and more putting attention to the communication of that. So before going on, though, I want to share about our team at the Sea Level Center. I have the privilege to work with really an incredible group of scientists, technicians, data experts, and this is how ChatGPT describes our work by looking at our website. You don't have to read it. Language models are great at taking text information and condensing it down. And really the key word here is about data, good quality data that the Sea Level Center produces. I think good data is the foundation for any type of science that we can build up. So what do we do at the Sea Level Center? Well, one of our major missions is operating a global network of tide gauges. We operate close to 100 tide gauges around the world with a tropical Pacific focus. And then through our partners like NOAA and other international groups, we also compile data and perform quality control on it. More and more, we're also focusing locally on the Hawaiian Islands, installing new tide gauges. And I will say all the imagery and analyses in this talk are generated by AI, including this figure. This is a time series similar to what we saw on the screen this morning. The tide gauge record at Honolulu. This is a tide gauge that NOAA's been operating since 1905. And what's shown on the screen here are the monthly sea levels. And you can see the variability on all different time frames, including the long-term trend and the more recent trends. So you can start to see evidence of accelerating sea level rise. My research interest is especially on faster variability, year-to-year or seasonal variability in sea levels. This histogram, this is showing in red the hourly sea levels at Honolulu in 2017. You might remember that was a year of very high sea levels around the Hawaiian Islands, compared to last year in blue, with the pink being the overlap. And you can also put this into some context of the coastline. So here the 0 line is the average highest high tide each day. And for Honolulu, we know from experience that coastal flooding starts to occur right around the 30 centimeter, 1 foot level above that high tide line. So how do we take sea level information and put it into the context of the coastal impacts? Well, to do that, we need tidal datum information. I showed on the previous slide everything with respect to mean higher high water, that average high tide line. That's what you see here on the left. And then on the other side, mean lower low water, or all tide gauges have a reference frame, a standard station 0, we call it. But we can easily change these datums into any reference frame that we would like. We also use tidal datums to take outlooks of the future and to put it in the different reference frames for the coastal impacts. This plot, this is showing the tide calendar prediction for Honolulu this month. The red circle was the high tide this morning. And you can see a high tide that was above what's normal for average high tide, but less than the previous week. I mentioned before about new tide gauges in Hawaii. Our team, just in the past couple of years, have installed 11 new tide gauges throughout the Hawaiian Islands. One of the new tide gauges is in Haleiwa Small Boat Harbor. And these plots here are comparing the tidal amplitudes at Honolulu with Haleiwa on the North Shore. You can see the smaller amplitude at Haleiwa, and the high tides running about an hour and a half before Honolulu on average. Okay, so I mentioned all of this is AI generated, so how is that possible? Well, you can see this video playing through where I've prompted it for, I've asked it to make the time series plot with the trends. The AI is generating code and then executing code, circle spinning, and then coming up with a analysis. This is just like what the plot I just showed is. This is the engineering schematic for that product. It was developed by Nemo Komar. He's a software engineer with our group. We're calling this tool Station Explorer Assistant, SEA. And what we've done is taking a large language model, in this case GPT-4o from OpenAI. We've given it access to data from our center, custom instructions for working with that data. And then what I think is really neat is Nemo set up a dedicated compute space, and we've given the AI access to that. So here I'm showing examples where I'm the user interacting with a large language model that has our database, instructions, and then a compute environment to execute code. Just a couple more examples. This tool is built to be a data curator. So running through some prompting where I've asked it to do a couple other things like look at the annual cycle, calculate some sea level anomalies. But then at the end, I asked it to output the data as a CSV file, which if I wanted to, I could save that to the computer, analyze it on my own, or I could copy this code and make some modifications. What I've been surprised about is we're finding that this tool is learning to do things that we didn't train it to do. So here, looking at some annual cycle stuff, but then at the end, I'm asking it to do power spectra analysis, just as an example of something we did not train it to do, but in its knowledge base, it's figured out how to do that. It will go download software packages if it needs it. It will install it on our computing environment and then execute the code. But I will say this tool can and definitely will make mistakes. If you look at the units on here, it's a little hard to see, but it says period in years. That's wrong. It should be in months. A quick prompt to it to check the units, it should fix that. But this is a known aspect of this technology. So I want to start to wrap up with questions that are on our mind about this. This is really new to us. Is it trustworthy? Is it safe for the users? Is it secure? And maybe most importantly, is it useful? And I think the answer to all of those questions at this stage is only that I hope so. We haven't tested it on that. Just as an example about the security aspect, so we're giving a very large model access to a computing environment, and there are risks associated with that. We put a guard dog in front of the compute, but we don't know how good it is. So that's just one example of what we're researching. A more general question I've just started to wonder about, and it's kind of started by some teasing from my colleagues. Are we developing an app that's going to replace me? And as I increasingly do these days, I turned to ChatGPT and had a bit of a conversation with it. And I asked ChatGPT to summarize the conversation with some plots. And this is breaking it down into what I think I do as a climate scientist. I analyze data, I communicate like what I'm doing right now, and I also initiate new research ideas and hopefully see them through to conclusion. Me, I think this technology's already surpassed what I'm capable of doing for data analysis, especially when you think about the scaling potential of this. For the communication, I don't know. I'm up here giving this presentation, not ChatGPT, but honestly, I wouldn't be surprised if that's not too far off. But I think the last question about initiating ideas and seeing it through to completion, that's the part to me that is really the major question at this point. And I'll leave to you what the implications of that question might be. But just to end on, this is the last slide, this product's ready for early testing. We actually really appreciate if you give it a try. There's an info page that you can go to. It has conversation starters that you can click on and start interacting with it. It definitely will make mistakes. It has bugs. Maybe you'll break it. That's okay. But just if you do test it, please let us know, because we're working towards hopefully making this better. Thank you.